Hello everyone and welcome back. So this time we're going to be jumping into the second of our Python lessons. It should be called something like Numeric Variables when you downloaded it. So go ahead and click that, open it up, and it should pop up this screen. I'm going to move myself over to the right. There we go. Now, earlier I said that Python is an object-oriented language. Now what does that mean? Well, it means that every variable you create in Python is an object. So if I type in a variable named variable1, it's an object. It's stored. It's saved in Python. And then I can make it anything I want. So it can be a number at one point in my code, and I can reuse that same name and say, well, now you're a list of numbers. Now you're just text. Now you're a function. Now you're a whole host of different things. Other languages, you can't do that. There's something called statically typed, which means that whatever you say it is at the beginning, that's what it is at the end. And that's got its bonuses and its fallbacks. One, you can't reuse names. And two, I don't know. It's a lot more work. You have to declare your variables. I don't like it. But then again, I love Python. So if that sounds like fun to you, go learn Java or go learn C#, I believe, does the same thing. All right, variables. Now we're learning about number variables. So what we learn is that a variable in Python has three parts. One, a name. The name can't have spaces in it. If you want spaces, make sure you put in underscore. It'll look kind of like a space, and that's typically what I do to make my variables very readable. Two, to set that variable, you have an equal sign. You don't have to put a space around it. I just do to make it look nice. And then three, you have something on the right that will give you a number, text, a function. There's 1,000 things it could be. In this case, it's a number because we're learning about numeric variables. So variable 1 is now 45. If I type variable 1 any other time, Python will go say, okay, where's that object? Go find it and say, okay, that's equal to 45, and then use that number. So in this case, I set two variables to two numbers, 45 and 60, and I make a new variable called sum of variables, which is just those variables added together. If you're wondering what's going on right here, this is called a comment. It's how you add notes in your code to tell what's going on. We do that with a hashtag. The code cannot see anything past that hashtag. It reads from left to the right, so once it hits that point, no idea what's going on for it. But you can read it, and that's the point. So some variables in this case would be 105. Okay, now let's do an example. So I started this actually last time, and my screen started flickering, so I had to stop, but it's back normal. So what it's asking us to do in this example is we're going to create a variable named profit, which I've done. And we're going to put an equal sign next to that. And I said I want that profit to be equal to the difference between my income and expenses. Okay, income here, expenses there. So difference would be a subtraction. Income minus expenses. Okay. Then print this value out. We learned about print last time. I go print. And do not put it in quotes now because this is now a variable. The variable is storing something. Print will just figure it out. It's only when you're trying to put just text in there that is not a variable that you have to be careful. So print profit. And if I run this, hopefully 2,183.72, plug it in your calculator, hopefully it's right. I didn't actually check to see if Python is doing the math correct. I just trust it. Maybe it's lying to me. That'd be horrible. Okay, now if you want to see if you got this right, if you want to check yourself, make sure everything's good, you can click this button right here. And it'll say all checks passed, you all good, you did it. I don't have this for all of my examples. Eventually I will, but this is just a whole bunch of Python magic that is going to tell you what you did wrong. For example, if I accidentally add these, I'm going to run it again. And you add the values rather than taking the difference. Try again. It'll tell you what to do. Once again, I don't have that for all the examples. I will eventually, probably, but not yet. For now, it's just walk through it. I gave you the solutions online if you need help for most of them. Okay, so we can have numbers. We can do add, subtract, multiply, divide, just like in Excel. And then we can print out the number at the end once we've figured out what we want. If you're doing some sort of math and you need to keep that number, you need to store it as a variable. So make sure it's to the right of an equal sign and that you name it something. Now, if you're wondering what all this craziness right here is, You don't have to learn it. It's actually not that crazy. It's just something called an assert statement, and it just makes sure that something is true and throws you an error if it's not. But just ignore it. That is just me giving you a way to check your answers. Okay. Now, let's learn about the different types of numbers in Python. There are two. There are floats and there are integers. Integers are whole numbers. Floats have a decimal point. Okay, so let's try it again. Let's take those two numbers from earlier, and we're going to assign them to the variable sum of numbers. We're going to print out some numbers to the terminal. Interestingly enough, this guy actually still knows that the variables income and expenses exist. So I'm going to use that. So sum of variables equals income plus expenses. Okay. And then I print out some numbers to the terminal. So print sum of numbers. Okay. And I run it. Oh, sorry. Sum of variable. My goodness, I'm sorry. Sum of numbers is what this should have been. There we go. Boom. And we got it. But wait, what is this 1 right here doing? 6873.28, those numbers do not have that many decimal places. This is why you have to understand the difference between floats and just your regular decimals. Python does its best to store these numbers. However, it's doing it in binary. And sometimes it will have these little issues because of floating point errors. It's where somewhere way down the line in binary, it accidentally has a little bit too much or a little bit too little, and it'll have an extra 1. We can get rid of those if we want to. We can round it off if we need to. However, you need to know about this because if you're doing something 1,000 times, let's say I was just adding these two numbers and then squaring them 1,000 times for some random reason. Those floating point errors would begin to add up, and eventually they might change my number. So this is an issue that all codes have. Okay, so be careful about that. The second one is called integers. They're whole numbers. Now, you're thinking like, okay, floats had an issue. What's the issue going to be with integers? Well, try doing 3 divided by 2. That should give us 1.5, shouldn't it? Let's see. So division equals 3 divided by 2. Okay, and then print division. So let's see what happens with this. 1.5. There's no issues. Integers, if it's going to give you a decimal answer, it gives you a decimal answer. We don't have an issue here. So they're pretty tame. Don't worry about integers. It's just if you need decimals, which you almost always do, you got to use a float. And you don't have to define it. It will just do it if it has a decimal. Okay. But with that, we're going to stop here. And next time we'll learn more about numbers in Python, other things we can do to get rid of those floating point errors and to make our numbers look nicer. So I hope this helped you, and I'll see all of you next time. Bye-bye.